What if, right now, another planet were slowly turning in the cosmic void, frozen in total silence, yet full of secrets still waiting to be discovered? Not an imaginary planet, not a movie invention, but Mars, the real one. Rugged, motionless, red. What you're about to see in this video is not an animation. Every image comes directly from the rovers that have roamed its surface alone, facing the cold and the dust. Spirit, opportunity, curiosity. You may have heard those names, but behind them lie pioneers of metal, the first explorers of an alien world. They don't speak, they don't write, but they observe. And for more than 20 years, their cameras have captured what our human eyes cannot see directly: the surface of another world. Desert panoramas, ochre hills swept by the wind, ridges eroded by time, and all of it, image after image, has been patiently transformed into breathtaking mosaics. But why don't we see these videos more often? Why do these images always seem so rare? The answer is simple. Mars is far, very far. The distance varies, but it can reach up to 400 million kilometers. And sending a single high-quality image is like trying to transmit an entire movie with a broken antenna from another world. The rovers have only a few minutes each day to transmit their data, and their bandwidth is slower than 1990s modems. So, no streaming, no live camera, just photos. But what photos? Every picture sent from Mars is precious. It's deliberate, oriented, calculated. It's not just a click. It's a fragment of alien terrain, frozen before the light changes, before the dust covers everything. And like a colossal puzzle, each photo is later assembled with others to form a Martian fresco. This titanic work gives birth to panoramas made of billions of pixels. The most famous of these mosaics, taken by Curiosity in 2019, shows the region of Glen Torridon at the base of Mount Sharp. 1.8 billion pixels, an image so detailed that, printed full-size, it could cover a football field, and you would still see individual grains of sand. Why Glen Torridon? Because that area contains clay. And on Mars, clay is a precious clue. It means there was water, not just a few drops, not a fleeting rain, but a wet, stable environment, potentially hospitable to life. In these images, we see far more than rocks. We read history, sedimentary layers, drying cracks, patterns carved by wind, a silent geology, yet eloquent. And then there's the sky. The Martian sky is nothing like a uniform one. Sometimes reddish, sometimes pale. It can also turn blue. Yes, blue. A cold, strange blue that appears on only at sunset, because Mars's thin, dust-filled atmosphere scatters light differently than Earth's. Here, blue sunsets are normal. And sometimes, by adjusting colors for scientific reasons, the images show Mars as if we were standing there with our own human eyes. But these photos are not illusions. They reveal a planet that seems dead and yet never stops speaking to us. Mars is not only silent, it's dangerous. Every rover sent there faces a hostile world, freezing temperatures, planet-wide dust storms, relentless radiation, and yet they endure. They move forward. They fall, but leave their mark. Take Spirit, for example. This rover, designed to last 90 Martian days, survived more than 6 years. It climbed hills, analyzed rocks, resisted brutal winters, until one day its wheels sank into soft soil, impossible to escape. So Spirit became a fixed station, sending its last signals until the Martian night finally embraced it. Then came Opportunity. It too was meant to last 3 months. It endured for 15 years, It traveled 45 kilometers across Mars, braving the seasons, exploring craters, surviving storms, until the one in 2018, a global storm that plunged the entire planet into darkness. Deprived of sunlight, Opportunity lost power and fell silent. Its final message, translated by NASA's team, moved the whole world. My battery is low, and it's getting dark. It was just a robot, but it had captured millions of human hearts. And then, a turning point came. In 2021, something unprecedented happened on another planet. A small craft, barely larger than a hobby drone, lifted off from the Martian ground. Its name, Ingenuity. This helicopter weighed less than 2 kilograms, and yet it flew in an atmosphere 100 times thinner than Earth's, an almost impossible feat. Its blades spun at over 2,400 revolutions per minute to generate enough lift. That flight marked a historic moment, the first powered flight on another planet. Ingenuity was supposed to make 5 short test flights. It accomplished more than 50, flying over dunes, inspecting rocks, scouting paths for perseverance. It became more than a technological demo. It became a scout, a promise for the future. Because if we can fly a drone on Mars, what else could we do? Fleets of drones exploring canyons? Flying modules inspecting underground caves? Autonomous swarms scanning the surface for traces of past life? Ingenuity opened a new chapter in exploration, the third dimension. But exploration is not enough. One day we'll have to live on Mars, and that changes everything. Mars is not a terrestrial desert. It's a toxic, frozen, hostile world. Its atmosphere, 95% carbon dioxide. Its pressure, so low your blood would boil without a suit. Its gravity, too weak to maintain your bone mass without constant effort. And the soil, filled with perchlorates, chemical compounds dangerous to human health. So why go there? Because it's our nature to explore, to go further, and maybe one day to survive elsewhere. Experiments have already been conducted. Scientists have managed to grow tomatoes, quinoa, and radishes in simulated Martian soil, not alone, not naturally, but with organic waste, microorganisms, and precise adjustments. It's not agriculture, it's survival. So, where do we live on Mars? Certainly not on the surface. Cosmic radiation there is lethal. Nighttime temperatures drop to minus 100 degrees Celsius. And every dust storm can last for weeks. But there is one solution: the Martian underground. Mars shelters vast lava tubes. Tunnels formed millions of years ago by volcanic activity. Some stretch for kilometers, with ceilings tens of meters high. Cold, yes. Dark, yes. But stable, protected, perfect for a base. And to live there, no need to ship houses from Earth. We'll 3D print them on-site using Martian regolith. Some concepts even integrate ice or fungal mycelium to create living habitats, capable of self-repair. It will be an architecture of a new world, a fusion of technology, biology, and adaptation. But living on Mars is not just physical survival, it's mental endurance. Imagine yourself a cramped module, the same faces every day, an endless red desert outside, no way to go out without a suit, no rain, no wind on your skin, no live calls, only messages, delayed by minutes. You eat freeze-dried food, you ride a stationary bike every day to keep your bones strong. And sometimes you look out the window and you wonder, why? Why did humanity choose this barren world? Why leave Earth? And maybe you'll understand, because it's in our DNA, because we are programmed to explore. And because one day, perhaps Mars will no longer be hostile, but a second home. Mars is not just a goal, it's a mirror, a red reflection of what Earth could have become. or what we might become one day. Cold, desert, silent. But beneath that silence, there are traces of ancient water, of dried riverbeds, of sediments carved by time. And one question still lingers. Was there ever life on Mars? Not civilizations, not little green men, but maybe bacteria, simple life forms buried in rock, shielded from radiation, existing billions of years before us. Every soil sample taken, every chemical analysis, every image transmitted brings us closer to that answer. And if the answer is yes, then Mars is no longer a dead planet. It becomes the second known place in the universe where life once existed, and that changes everything. Mars seems calm, but that calm is a lie. Every few years, something ancient awakens, a phenomenon we still don't understand. Planetary storms. They begin as a simple gust, a small swirl, then another, until the entire sky is swallowed by dust. In 2018, one of these storms engulfed Mars for months. It killed opportunity. Deprived of sunlight, the rover could no longer recharge its batteries, and its heart stopped. This dust is not ordinary. It's electrostatically charged, so fine it seeps into every system. It hangs in the air for weeks, blocking light, cutting communications, paralyzing missions. And the worst part, we still don't know why they form, nor how to predict them, nor how to stop them. Every storm is a reminder, a warning. Mars is not passive. It defends itself. Mars fascinates, always has. A red dot in the sky, a symbol of war, mystery, and possibility. But today, though, it's no longer a dream. It's a destination, a tangible goal, a mirror of our future. It's close enough to tempt us, but deadly enough to remind us we don't belong there. Not yet. And yet, space agencies persist. They plan, test, prepare the launch. Because deep within Martian rock, or buried in the layers of an ancient, forgotten lake, there may be answers to our origins, to our cosmic loneliness. Every image, every grain of sand analyzed, every meter traveled, brings us closer to one historic moment, the first human on Mars. It won't be a conqueror. It won't be a movie hero. It will be a scientist, an explorer, a human being carrying within them all our fears, all our hopes, and everything we are. So when that day comes, when a silhouette appears on the red dust, facing an Earthrise on the horizon, remember this: it won't be the end of the journey, it will be the beginning of a new chapter for our species. A chapter where our sky will no longer be a limit, but an invitation.